Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So, in this video, I would like to explain about how to draw an orbital overlapping in ozone molecule. Right, so first of all, we need to draw a correct Lewis structure. So, a correct Lewis structure for ozone is like this because we have 3 oxygen. If we can see, we have 3 different types of oxygen. Let's say we call it, so I label this as oxygen number 1, this is oxygen number 2, and this is oxygen number 3. Oxygen number 1 only have 1 bond, oxygen number 2 have 3 bond, and oxygen number 3 have 2 bond. Alright, so it is a multiple bond. So we know that only oxygen number 2 and number 3 will undergo hybridization because it's involved in a formation of multiple bond. Alright, so the next step is to identify the types of bond. This is sigma bond, this one form 1 sigma, 1 pi. Because only oxygen number 2 and number 3 involved in the formation of multiple bond, so both will undergo hybridization. Okay, if you can see, for oxygen number 2, it have 2 sigma bond plus 1 lone pair. Because 2 plus 1 equal to 3, it undergoes sp2. For oxygen number 3, it have 1 sigma bond plus 2 lone pair. Because 1 plus 2 equal to 3, it also undergoes sp2. Alright, so the problem now is, if you still remember, in the early stage when we learn about the chemical bonding, I already mentioned to you about oxygen supposed to have 2 bonds in order to get a formal charge equal to 0. It can be left and right or form a double bond. So in this case, we have oxygen only form 1 bond and oxygen that form 3 bond. Okay, so because of that, we need to determine the formal charge for each oxygen involved. Alright, so if you calculate the formal charge for the first oxygen, 6 minus 1, it will become negative 1. And for this one, 6 minus 2 minus half of 6 become positive 1. And this one is 0. The overall charge is 0, but each atom itself have their own formal charge. So, because of that, so we have to draw a ground state for the central atom as oxygen plus. Okay, now oxygen number 2, now I write for oxygen number 2, which is O plus ground state. So we know that oxygen have 6 valence electron. When it's become a positive ion, it's only have 5 valence electron. This is 2s. The central atom have 1 lone pair, so we need to keep the lone pair. So O plus excited state and O hybrid. We need sp2, so we blend this. And we have another 2p orbital. Okay, for oxygen number 3, it is oxygen. So we write the ground state that consists of 6 electrons. And we need to keep 2 lone pair. So and we need to hybrid sp2. Okay, and for O number 1 or oxygen number 1, it does not undergoes hybridization. So we write the ground state for O number 1, which is O negative. So it's have 7 valence electron because it gained another 1 electron. Okay, so it's time to drawing. For sp2, the shape supposed to be trigonal planar, and this one also. Okay, for a trigonal planar, which is O plus, so the shape supposed to be 1, 2, 3. This is sp2, this is sp2, this is sp2, and it represents O positive. Okay, we have a lone pair. Maybe I can put the lone pair here, and we have 2. Okay, this is oxygen number 2. It will undergoes overlapping with oxygen number 1. Okay, oxygen number 1 only have 1 available orbital for overlapping, which is 2p orbital. So I can draw here this is 2p orbital. It represents O negative, another 1 electron, sigma. And on the other side, oxygen number 2 will overlap with oxygen number 3, and oxygen number 3 undergoes sp2 hybridization. sp2, the shape supposed to be trigonal planar. This is sp2, sp2, sp2. It is oxygen. It brings 1 electron, form a sigma bond. So we already draw all the atom. Now we have 2p orbital and also 2p orbital. So we have to appear. So this is 2p orbital at O plus, and this is also 2p orbital at oxygen. So 1, 2, atas, bawah, it will form the pi bond. So it is correct. It will form oxygen plus will form 2 sigma bond, and at one side it form a double bond. Okay, so that's all. Thank you very much.